Sadly brilliant. Why are brilliant motorbikes unfortunately also so expensive? That's the question we're getting into in this video. A warm welcome to 1000 PS TV. Hello Martin, a warm welcome here to the 1000 PS Racelab studio. Right then Martin, today we're looking at a topic. It's all about money. It's early December now, and in Austria there's Christmas pay. I don't know if in all the other countries it's the same, that a big windfall lands in household budgets. And we're asking ourselves, why is a Yamaha R1 actually twice as expensive as an R7? And why are things that are fun on a motorbike inevitably tied to higher costs? A few things are pretty plausible to explain, pretty easy to explain, but some things are a bit surprising. If you were to go into a vocational school now and had to explain to first years what the three things are that make a motorbike expensive, what would you say? What would you say are the three things that make a motorbike expensive?
First and foremost, overall performance. Performance covers quite a lot. It starts with handling, but of course the engine is largely responsible too. We're now talking about well over 200 horsepower in top engines, especially when it comes to superbikes. And you already mentioned the R1. We're somewhere around that range. And it's obvious that I need the corresponding revs here. At such high revs, I then need materials that can actually cope with those loads. It also continues in the direction that I have to reduce the weight a lot, because with such powerful bikes, the handling and the ride behavior have to be optimized as well. Even in the engine, I already have to resort to magnesium and titanium parts in places which are of course significantly more expensive in material cost than relatively simple materials like normal aluminium castings, simple steel grades. There's a huge difference there. With high loads in the gearbox, I also have to apply certain hardening processes that wouldn't be necessary on a weaker motorbike, because the surface pressure on the gear flanks doesn't get anywhere near as high.
So I've condensed that, Martin. I don't know if we're on the right track. I've already teased out three things: revs, weight, and power. Put it bluntly, define how expensive the fun is. We'll get to economies of scale and so on, but let's try to break it down. Why do revs make things expensive? Because revs somehow mean the engine components are loaded much higher. What is it? Squared, I think. The higher the revs, the more expensive the material has to be so it can withstand the revs.
Exactly. You can imagine a piston having to move up and down hundreds of times per second at very high revs. You can imagine what acceleration that means for the piston and for the crank train. And of course, I need extremely strong, reliable materials, often very highly controlled components. That means it's not enough to make the material good. Sometimes special inspection mechanisms have to be used before I then install them in the engine, because everything is pushed very close to the limit. And if I want to prevent engine failures, I have to check the components more closely. So I have additional work steps that are necessary compared with an engine that operates further away from its stress limits. And since nowadays, despite these powerful engines, people still want certain mileages and also try to stretch service intervals further, I simply have to invest significantly more in the manufacturing of these bikes in order to deliver those attributes. And that is of course the reason, or one of the reasons, why these bikes end up significantly more expensive.
Yes, and I think what's relatively easy to explain to people, because luckily it's the same across all hobbies, mountain biking, road cycling, and well, many others, is that low weight simply costs money because lighter components, titanium, are more expensive than steel, both in production and in machining. And a carbon composite is just more expensive than a glass fiber composite. So put simply, everyone can grasp that, it's kind of logical. And then we come to a misconception that's also incredibly tricky for manufacturers, because actually displacement per se isn't expensive. If I say I make 150 horsepower from 1000 cubic centimeters or 150 horsepower from 750 cubic centimeters, the 750 could actually be more expensive than the 1000. But the manufacturer sells the 1000 pricier than the 750, and that's a challenge, right?
Basically, displacement, as you say, isn't really cost intensive. So a 1000 engine can basically be produced at similar cost to a 750 engine. That's absolutely right. But bikes are still divided into certain displacement classes, because for the user, there are other costs attached. In many countries, levies on motorbikes, be it insurance or tax, are calculated based on displacement. And that means I naturally have different costs with a 750 engine compared with a 1000 engine. What also comes into play is that if I don't change the engine concept much, but just increase the displacement, the engine physically gets bigger. In terms of riding dynamics, a 1000 engine with the same engine principle can't be ridden quite as agilely and playfully as a 750, which is smaller, slimmer, and more compact as a result. So with engine size, I'm not only keeping an eye on cost, where I'd say a large capacity engine is more or less the same price, so I'll just make large capacities. That's not the case, because with smaller capacity engines or smaller displacements, there are advantages for the consumer. The bike as a whole becomes a bit lighter again, because a large capacity engine is a bit heavier than a smaller one, and in everyday use it's also significantly cheaper in terms of levies. So you're not just focused on getting more power through displacement, you're trying to find a compromise, otherwise you'd only build large capacity engines.
That sets the stage nicely for our Yamaha R9. It's edging into short a bit, and there are two interesting aspects in there. In principle, it's meant to close the gap that the R6 more or less left behind. We've now basically got a 900 engine instead of a 600, where the power is cheaper to extract because of lower revs. On the other hand, the crankshaft still stays slim, because in the 900 engine, where I've only got a 3-cylinder, the crankshaft is slimmer and more compact. What do you think, Martin? If I've got the 900 and then I put my R6 here next to it, how many % less riding fun do you have as a dyed-in-the-wool racer on a motorbike where they kept an eye on costs and development, and cost really was a topic? The 600s were practically unsellable at one point. What do you feel out on the road? Does that thrill of having those high revs go away? Or that last finesse in the titanium alloy? What do you feel out there? Where does the riding fun get lost a bit? And where is it completely irrelevant and you can just be happy you're saving 2,000 euros? What do you think?
If you lean a bit towards racing, those extremely high revving 600s do have a lot of flair, because they're set up so that peak power arrives at high revs and they rev out very aggressively at the top with a lot of power. On the road, people have been having less and less fun with such bikes, because these high revs now cause too many problems on the road, noise and so on, restrictions, and you have relatively little power at the bottom compared with the top. That hardly matters on track, but it absolutely does on the road. On the road, first and foremost, I want power from low down, so I don't have to laboriously rev it out all the time for something to happen. And that's exactly where these bikes now come in. Manufacturers have seen that sales for, say, 600s or these small high revving capacities on the road were no longer in demand for the reasons mentioned, and have taken a slightly different approach as a result. They wanted to generate bikes with similar peak outputs, but with the big advantage that they now perform well from low revs too. And that's exactly where, for example, this R9 comes in as a replacement for the R6, where you benefit from the bike being inexpensive to manufacture, therefore not carrying such a high price, and bringing more benefits for road use, because these engines, thanks to the larger displacement, simply release more performance from low down, and that generates riding fun on the road. If we look towards the racetrack, the relationship is a bit different, because there it's about really revving out at the top. You know, on track, you're almost always on the limiter. You're shifting up there. You maybe only ride 2,000 to 3,000 revs below the limiter and operate in that zone. And when you're in that peak power zone, that's where it's really fun on the racetrack. In a direct comparison, the R9 is very lethargic at the top. The main focus is that the best power is delivered in the lower and mid-rev range, which is exactly what I want on the road. But if I then go to the racetrack with it, it naturally always feels extremely sluggish at the top, because towards the limiter, it doesn't really pile on more, it actually flattens off.
Martin, that was a cracking... The way you describe how close you are to the maximum rev point isn't close to my reality. For me, for example, I've rarely hit the rev limiter the stronger the bike was, and with everything you've just described as a downside, I get this nice warm feeling in my stomach where I think that's exactly my kind of bike. I don't want to be faffing about up there in the last 2,000 revs. I don't shift that precisely anyway. I'm just glad if I don't have to play up there. It does have a certain fascination from a different angle. If I make a riding mistake with a 600, I've still got a bit of rev headroom up top unexpectedly if I need it. Whereas I'd have rev headroom lower down on a 900 if I'm setting sloppy shift points. So I'm sure that for me this is the better concept. But I think I'm with you. There are people who long for those revs. They're the ones who talk about exact shift points. I can't tell you which corners I ride in which gear. I'm not really bothered. I just ride in and see what fits. But if you're someone who's addicted to revs and thinks that's brilliant and also changes the gearing, I've never done that either, then I don't think you can simulate that feeling with the more affordable 900s. But I'm curious when we actually get the stopwatch out, because we've got two projects this year. We've got the R9 and new info for you. I've bought myself a ZX6R as well, privately. So I've got a true 600 and a 900. Let's see which one I end up being quicker on. And then we've exactly got the effect. How many revs do I actually need as a hobby rider for lap time? But Martin, we also have to address another topic, because behind the camera there's a Panigale V4. What is it? I think it's a Panigale V4S. You can hardly tell anymore when there's so much carbon and bits and, well, you name it, bolted on. They're Krapovic exhaust systems. So 4,000 euros or something like that. Erlin's shock, no idea. Probably 2,000. The fork, somehow 7,000. Brembo anchors, 3,500 or something. So, pricey parts, expensive materials, tight tolerances in production, lots of manual work, top-end materials that are expensive to process in production, all logical. What some people might not realize is that the Panigale riders 10 years ago footed the bill for the IMU and the traction control that I now have in my, Panigale 5.2. I think you can put it like that. That's it. The early adopters pay the development costs of the rider assistance systems, the ones who have them first, let's be honest, and the others then get them thrown in cheaply or for free, right?
Exactly. The developments on the electronics side, which in recent years have become ever more prominent, because of course with powerful bikes there are increasing calls for rider aids. That's why manufacturers try, especially on these bikes, to tune the rider aids particularly finely so that they work well. And so the entire development when it comes to electronics and rider aids is primarily carried out on these bikes, these high-performance machines. That's where they first moved to 6-axis IMUs to detect the riding state precisely so they can regulate things very finely. And exactly those developments are attributed to that segment. And that, of course, increases costs. The advantage is that these rider aids were developed exactly on that bike, and coming back to the start, they contribute to performance. So everything that is performance costs money, and that's exactly the point with these powerful bikes and high-performance superbikes like the one we're standing by here, that you take the overall performance to the top level. And that's not just about engine power, but also about handling, dynamics, and these rider aids. That's why the developments are done primarily on these bikes and then trickle down to the slightly simpler models, because there we say we don't have as much power. The control doesn't have to be quite as sensitive. We can use simpler sensors, not detect quite so many axes, fit fewer sensors, and so on. And of course, that means different costs to consider. And it's also a reason why an R9 costs significantly less than, for example, a Panigale V4.
Yes. And then it's also the case that these effects don't only run down within the same model category, but also across modular platforms into other model categories. So BMW made the S1000RR. That was the first time BMW introduced rider assistance systems at that level. The S1000R then benefited, which could be offered more cheaply because the RR customers had already paid part of the bill for the electronics development. And you also have to say, all right, they were also the first to enjoy traction control on the racetrack back then. That cost money too. But now we're slowly arriving at economies of scale. It's naturally also a self-reinforcing effect. I've got an expensive product, fewer people buy it. Then the manufacturers also have to take care in development. Okay, fewer people buy it, which means I have to spread these development costs over fewer units. And that, of course, makes it even harder for smaller, more exotic brands with a smaller portfolio, because the bigger manufacturers like Yamaha bring the R9 engine into lots of different bike concepts. And, well, I don't know, Martin, you've suffered through this already. You've been involved in various developments. Where's the sweet spot? What's an example where you get a lot of value for a product, where it's really been solved well? And where do you clearly see as a customer that you're simply paying because only 1,000 or 2,000 people buy the product? Where, from your point of view, is the starkest difference from these economies of scale?
As you've said, it massively depends on what final production volume I get. And that's exactly with these high-performance motorbikes, which by their very nature sit at a very different price level. I only hit a smaller group of interested buyers, and as you say, that generates even higher prices through these economies of scale. That's exactly where a bike like this steps in, where you try, via very broadly applied component use, modular design. If you then make a naked bike from it, you also use the same chassis, for example, the same swing arms, the same engine. The three-cylinder 900 engine is already installed in many Yamaha models, for example. So you tackle it everywhere and try to increase volume significantly in order to get through at lower cost. I can't really name a specific example there.
This MT09 R9 Tracer 9 is a good example where you try to use economies of scale smartly. We can't think of anything better because it really is the case. We'll get to a very good level of lap time for an acceptable price. And if we now look back, because what makes it even worse is that used bikes also have that supply and demand theme. Brilliant bikes stay brilliant, and they also stay brilliant in terms of value retention. It's a narrow target group, and they'll never be cheap. They naturally push prices up on the used market too, and so it will never be a bargain, even second-hand. Looking back, does a bike come to mind where you'd say, lap times to price ratio, where was it good? Where was the lap time to price ratio good? You've never bothered with that. You didn't care what it cost, did you?
We always used everything that made us fast. Maybe a bit back to the early days, if I think back.
When you had to watch the money?
No, not so much the money, more the technology we had back then. If I think back to my early days with the ZX9, for example. ZX9, you remember that too, you're about my age by now.
That was more a bike that wasn't really built for the racetrack and wasn't in the high performance realm. And so it was relatively cheap to buy. And with that, we were already riding well under zero at the Pannonia Ring around the turn of the millennium. And that was a bike that had 140 horsepower. So nothing extremely strong, no rider aids, still a carburetor engine. It was a very inexpensive bike to get, but still quite remarkable in terms of lap time. I have to say, that still impresses me more today, that you ride that kind of time with such a bike than if you now circulate on a supercurrent superbike at, around 153 or something. If you compare what we had back then in terms of technology and of course inexpensive bikes, and they were inexpensive because all that tech didn't exist yet. There was no fuel injection. It was still all manual riding. Those were the most memorable times, I have to say, when everything on the motorbike was still rather rudimentary.
Martin, that's an insanely good cue because lots of people feel that everything was better in the past. There was the GSXR 750, then there was the R1. There were loads of bikes that, even adjusted for inflation, were sold at really good prices back then, and with which you could ride genuinely quick lap times. And when you now see old used GSXRs and ZXRs on track, they're still making good progress because back then there wasn't any electronics in them. All the things we listed earlier that make a motorbike expensive weren't in there. And you still had the economies of scale that meant the bikes, I think around 60,000 units a year for the CBR 600, for example. Those are completely different volumes. In that sense, folks, a sad ending. In the past, everything was better, at least in terms of lap time bang for buck. On the other hand, I don't know if anyone would want to take a step back and give up the 200 horsepower we have today. So in that respect, we do live in good times. But post below what the sweet spot was in your motorbike career. Where do you think every 1,000 you put on the table led to loads of riding fun and really good lap times? Post your sweet spot below. Then in our used market, it'll be in high demand again, which is probably already the case. What are your experiences? Martin mentioned the ZX9R. I'll say the GSXR 750 was the sweet spot for price performance. What's your sweet spot? Pop your truth below.